Okay, our first example in section 4.4, r squared plus 7r plus 10. Again, we're asked to factor like in the last section, and just a reminder, anytime you're asked to factor, make sure you take a second and check to see if there's a greatest common factor, something that you might be able to take out of each one of the terms. R squared, 7r, and 10 don't have any common factor, so nothing that we're going to take out of these. Next up, anytime you've got a trinomial, which is what we've got here, where we've got 1, 2, 3 terms, trinomials are going to factor into 2 parentheses. So you might start off writing those parentheses, and then we're going to fill in some of the things that we know for sure. One like this one is fairly nice. The first 2 things in both those parentheses, those are going to multiply to be this first term, the r squared. And generally that's fairly simple. R and r both multiply to be r squared. Also, we've got a plus and a plus up top here, so that gives us an indication of what the signs are going to be in the middle of both those parentheses. And then the last part, I'll do this in green, or do this in purple rather. The last 2 things, these are going to multiply to be this last term, the 10. Going to multiply the 10, and in this case, since the coefficient of that first term is 1, I'll go ahead and write that. Coefficient is 1. They're going to multiply to be 10 and add to 7. So we're looking for a pair. And I'm going to write the list, the things that multiply to be 10. So 1 and 10 multiplies to be 10. Also 2 and 5 multiply to be 10. 3 doesn't go in. 4 doesn't go in. So this ends up being our entire list. And the only pair that multiplies to 10 and adds to 7 is 2 and 5. So go ahead and put that in. 2 and 5. And one thing that you can do to check this, and you don't necessarily need to do it here, but we'll want to do it later on when the coefficient of that first term is not 1. Multiply those two. 2 and r gives us 2r. Multiply the outside ones. 5 and r gives us 5r. And that does happen to add to our middle term, which is 7r. So that ends up being our solution, r plus 2 in the first parentheses, r plus 5 in the second. Our second example, factor s squared minus 9s plus 18. And again, anytime we see that word factor, we want to check to see if there's a greatest common factor. S squared, 9s, and 18. Can't take s out of everything, and no numbers that we can take out of each and every one of those terms. Second, it's a trinomial. So trinomials are going to factor into 2 parentheses, and we're going to plug in the things that we know for sure. Again, this first thing in both of those parentheses, those are going to multiply to be this s squared term. That's usually going to be the easiest bit, s and s. And we don't have a plus situation here. So we can go ahead and wait on inserting those signs just for a moment. These last 2 things in both those parentheses, again, are going to multiply to be the 18. And we want to write factors of 18 and just a little bit of scratch just to show what the factors are. 1 and 18, 2 and 9 make 18, 3 and 6 also multiply to be 18, 4 doesn't go into 18, 5 doesn't go into 18, and then we're back up to 6. So this ends up being the entire list. And in this case, we're looking for a pair that we can get to add to be this negative 9. And we could get negative 9 out of these 2 if they're both negative. Negative 3 and negative 6 add to be negative 9. So I'm going to go ahead and insert those. -3, -6. And again, you may want to do this. You may want to start practicing this because we'll have to do this later. But again, the first term is 1, so you're usually good with just doing this. But just to check, multiply the inside ones. -3 times s gives us -3s. Multiply the outside ones, s and -6 gives us -6s. Not sure if you can see that too well. But those do add to be -9s, which is what we were hoping to get. So that verifies that our factoring is correct. Example 3, factor v squared minus 50 minus 5v. And one thing that you'll want to do here, you may have noticed in the past, the first two examples, typically our trinomials will start with a v squared, they'll have a v term second, and then they'll have just a regular number like 50 last. So what we'll want to do here is rearrange. So writing that sort of lightly. But I'm going to go ahead and put the -5v in the middle. And put the -50 on the end. This is typically the way that we'll want to go about factoring. And then from there, just go through our regular steps. Greatest common factor. In this case, nothing that we can take out of all of them. Second, it's a trinomial, where we've got 1, 2, 3 terms, so that's going to factor into 2 parentheses. Again, the first thing is going to be pretty easy. Both those have to multiply to be v squared. And then the last thing in both those parentheses. And again, if this is plus and plus, we can go ahead and put the pluses in down below. But they're not plus and plus, so we'll go ahead and leave those for now. But these two underline, the last two things in both those parentheses, has to multiply to be 50. So factors of 50, and more particular, -50, since that's what we're hoping to get. So 1 and 50, 2 and 25, 3 doesn't go into 50, 4 doesn't go into 50, 5 does. 5 and 10. 6 doesn't, 7 doesn't, 8 does not, 9 does not, and 10 does. So we're looking for a pair that we can make -5 out of. So they want to multiply to be -50 and add to be -5. If we go with the 5 and the 10, we can get -50 if one of them's negative. We want them to add to be -5. So if we make the 10 negative, both of those would multiply to be -50, and they would also add to be -5. 5 and -10 gives us -5. So +5 and -10. And again, you can check this. I'll do it lightly. The 2 in the middle multiply to be 5v. The 2 on the outside, v and -10, gives us -10v. And those two do add to be -5v, which is what we had in the middle. Our fourth example, factor 2y squared minus 24y plus 72. Again, anytime we're factoring, want to check for greatest common factor. And in this case, hopefully you can see 2y squared, 24y, 72. We can factor out a 2. So this is the first example of one of these trinomials where we can factor something out. So let's go ahead and take that out. Can't take a y out of each term because the 72 doesn't have a y. So that's the only thing that we can factor out. Then I want to rewrite everything that's left. So I'm not doing the 2 parentheses thing yet. We're just going to rewrite each term with that 2 taken out. So if you take 2 out of this first term, 2y squared, you're left with just y squared. If you take 2 out of the second term, that 24, you're left with 12. And we didn't take any y's out, so we still have that y. And if you take 2 out of 72, you're left with a factor of 36. And then from there, we're going to continue to go further because this trinomial that we have here, I'm going to go ahead and underline it. We're going to factor that just like we've done the previous 3 problems in this section. So it is a trinomial, so it's going to factor into 2 parentheses. And even though we're not doing anything with this 2 over here, still going to continue to bring it down. So remember, first thing in both these parentheses, usually pretty straightforward. You want the 2 things that multiply to be y squared. And next we're going to look at the 36 and factors of 36. Those could be 1 and 36, 2 and 18, 3 and 12, 4 and 9. 5 doesn't go into 36, 6 and 6. So looking for one of these pairs that we can get to make negative 12 out of, and we can make negative 12 out of the 6 and the 6 as long as both of them are negative. If they're both negative, they multiply to be positive 36, and if they're both negative, they add to be negative 12. So we can go ahead and put those in. Let me do that in a different color. So negative 6 and negative 6, and you can check that again doing the inside and the outside things and just add those. See if they come out to negative 12y, which they will. And that's about as complicated as this section gets. Good luck.